the quadratic equation. If I want to say I want to apply this operation, but instead of x, I want to apply it to k, okay? There's a lot of words to say, right? Because I want to multiply k by itself plus 2 times k plus 1, okay? If I want to replace x with 23 as a constant value, then I have to say, okay, apply this operation to 23, which means I want to compute 23 times 23 plus 2 times 23 plus 1. That's a lot of words, okay? And I can make mistakes when I'm spelling out the exact operation that I want to perform. So I want to be lazy. And being lazy means, in this case, I would define a function called f. Okay? In other words, f of x is a function. F is a function of x. And the definition of the function is to say, whatever this thing is, I want to multiply it to itself plus twice of that value plus 1. That is the result of f of x. Is that okay? So x is a placeholder. Any questions about this? Nope. Which also means that I can apply this function f to just about anything. I can apply it to k, which means the result is going to be k times k plus 2k plus 1. Since I don't know what k is, I cannot resolve that equation. Well, I can simplify it, but other than that, I cannot do anything about it. What about f of 2? Well, 2 is an actual value, so I can write it out first. 2 times 2 plus 2 times 2 plus 1, and that will give me 9. Is that okay? Is everybody comfortable with the notation of a function? It is really just using a single letter to be defined to an operation, possibly very complicated, but then after the definition, I can just refer to the function f to refer to the complicated operation that is its definition. Is that okay? It's a shorthand. So after we introduce function, we'll introduce what an inverse function is. Now that is a little bit more interesting. Okay, an inverse function is a undo operation. Okay? So in this class, we'll use the prime symbol to mean the inverse of a function, because to the exponent of -1 is a little bit hard to type in a text editor. So I will just use a prime to indicate that. In other words, in this class, I will say, given a function f prime is the notation of the inverse of f. Just a notation. Just if you're taking calculus at the same time taking this class, just make sure you can still separate the two classes, because otherwise f prime becomes the first derivative of function f, which is not what we are doing here. Is that okay so far? Yes? Okay. So what makes f prime an inverse of f? In other words, given a function f prime and given a function f, how do I test to see whether f prime is actually an inverse of f and actually vice versa too? The answer is f prime of f of x should equal to f of f prime of x, and that should equal to x itself. Okay. In other words, they are basically undo of each other. One will do one thing, the other one will flip it and say, let's undo it. So you get the original thing back. Because if you look at this one here, x is the original item, original value. I perform function f on x. I get a particular value, possibly the same, possibly not the same, I don't care. But if you apply f prime to that result, you get x back. Okay? Is that okay so far? Let's do some examples. Let's make some examples that are kind of obvious. We'll just say that f of x is x plus 1. Okay? What do you think is the inverse of that? X minus 1, right? I mean, if I add 1 to x as f of x, in order to undo that to get x back, I just have to subtract 1 from the result of f of x. Can I prove it? Can I apply f prime to f of x and then get back x? Well, let's figure that out. So the first thing we want to do is to say, what if we apply f of f prime? Okay, this is an example. So let me just say for example. Okay. And I will save this file to make sure that we are going to save the entire file to today's folder. So this is, today is 2010-09-13. This is cisp300. Oh, it saved the file itself, didn't it? Okay, let's try it again. Try again. Create folder this time.
We should name it 300.
Oh, that's right. Okay, create folder. It does not let me enter a name for the new folder. So the question is, where is that new folder now? Did it get created? No, that's the file. It did not let me create a folder. That is a little mysterious. So we drop down to the command line interface. 2010-09-13 cisp300. Not a problem. Then we have to move the other file inside this one. 09-13 310. We have to rename it to. We'll rename it as text.txt. There we go. Now we have to make sure that we resave this file as that name, because otherwise next time I save it will save it to the old name, which is incorrect. So we have to go back here and say that we want to save it this name. Yes, overwrite. There we go. Okay. So now we want to try to double check and make sure that f prime is in fact the inverse of f and vice versa. So we start with this because by definition this is what should get x back. Yep.
Can you raise it up a little bit?
Oh, sure. Just hold on a second. Got a way to do it. Hey. Oh, okay. That's because I have I have it maximized already. The size control thing is not available. There we go. Better?
Yes.
Okay. All right. Okay. What does that equal to? What is f prime doing? Well, according to this example, f prime is just subtracting 1 from whatever is inside the parentheses, right? What is inside the parentheses? F of x. So this whole thing becomes f of x minus 1. Is that okay so far? We take whatever is inside the parentheses and then we apply the operation to that whole thing. If it is a constant, we apply the operation to the constant. If it is x, we apply the operation to x. If it is the result of a function, guess what? We apply that operation to the result of that function. Okay? But remind me again, what is f of x? According to this definition, f of x is x plus 1. So this whole thing becomes x plus 1, the sum minus 1. And what is that?
X.
After simplification, we get x back. So this is a basic proof that f prime is in fact the inverse of f itself. Are there any questions about the concept of an inverse function? No questions? Do all functions have an inverse? Can we undo everything?
No, some don't.
Some don't. Well, I can give you one quick and easy example. So I would say some functions do not have inverse. The simplest one is f of x equals 5. Okay, well, there's no restriction to say that the function itself has to refer to the variable inside the parentheses. So defining f of x equals 5 is perfectly fine, except there's no inverse function. In other words, I get 5, there's no way for me to reverse it back to the old value of x. Okay? There is no inverse for this function. We can try something else. We can say f of x equals 0x. That also has no inverse. Because after the operation, everything turns into 0. Well, since 1 maps to 0, 2 maps to 0, 3 maps to 0, just telling me the result was 0 is not enough to get back to what it was before. So there are certain functions that do not have any inverse functions. Are we okay so far? It's do good? Okay. So what we want to do now is to say, okay, what is a procedural method to deal with assignment statements? In other words, instead of treating each one of these cases, line 71, line 315, line 1, and line 23, on an individual case-by-case basis, can I derive a mechanical method so that I can just go through a series of tests and a series of operations so I can mechanically start with the precondition and end up with the post-condition? That's what we want to do. Okay, because if we can define a template and say, okay, if the expression fits into this template, we apply these operations and we'll get to the post condition. If it fits this particular template, we apply the other operation and we get to the result. That's good, because that way you don't have to think on a case-by-case basis. Is that making any sense? Yes? No? Maybe? Okay. All right. So we'll use an example. We'll use an example as follows. And we'll define line 65 to be x gets. Are you guys ready for something that's a little bit more tricky, or do you want to stick with the easy ones?
Stick with the easy.
Okay. Save the hard ones for the midterm.
Yeah, that'd be great.
Okay, we'll use an easy one in this case. Okay, so the statement says it is x gets x plus 3. And we'll have a precondition that says, don't ask me why, but before line 65 executes, this is guaranteed. So what is guaranteed is x, well, we can make it so that 3x is greater than z, and x is different from y, and y is less than 100. Okay, just picking some random relationships here. This is what we knew before line 65 executes. We want to find the post condition. So the question is, how do we do this in a more or less mechanical way? Okay. So here's step 1. Step 1 is to take a look at the right-hand side of the assignment. Call that a function. So in this case, we'll call it f of x. What is the right-hand side of the assignment?
X plus 3.
X plus 3. Okay, so we are now defining f of x to be the right-hand side. So f of x is x plus 3. Fine. So step 1 is pretty easy to do. You just look at the assignment statement, you extract the right-hand side and define a function and say function f of x is that. Step 2. See if that function, in this case f of x, has an inverse function. Can we reverse that operation? Remember, some functions cannot be reversed, but how about this one? We can reverse it. How do we reverse it? What is f prime of x in this case? Okay, x minus 3. Very good. Okay, and step 2.1, you can basically verify the inverse function. This step is actually fairly important, because some inverse functions seem to be correct, seems to be obvious, but they are actually incorrect. So it is always helpful to verify the inverse function just to make sure that it does reverse the operation. So in this case, we have f prime applied to f applied to x equals to f of x, excuse me, that was my phone. So this becomes f of x minus 3. But what is f of x? F of x itself is x plus